Welcome to another episode of the Practical SQL Server HA show. My name is Edwin Sarmiento and welcome to this show. If you're joining in for the very first time, thank you and welcome. The purpose of these episodes are twofold. One, if you are a technical operator, meaning you are a database administrator, systems engineer, sometimes an operational engineer, or even a developer who just happens to be sitting beside the database server, and you're the closest person there, now you're given the responsibility to manage it. And you are also responsible for your always-on availability groups, deployment. While I focus generally on the SQL Server high availability and disaster recovery space, unfortunately, though, Microsoft has pushed always-on availability groups so hard as kind of like the go-to high availability and disaster recovery solution for SQL Server, even though in most cases customers might not really need it. But of course, that does not sell licenses. Anyway, welcome. I did say it's twofold, right? The second one is for decision makers. Are you a CTO, a CIO, maybe the manager of the database team lead, and you have to make decisions based on your implementation of always-on availability groups, or maybe your team's not ready to support it. This is also for you. I'm past couple of weeks I have been focusing more on the troubleshooting aspect for two reasons. One, I posted a survey on social media a couple of months ago, asking people about what kind of content, what kind of topic they want me to focus on these episodes, and one that came up to the list, the one that is highly requested, was all about troubleshooting. And so I kind of have a series of topics around those, and I don't want to call it a series because it's not an end-all be-all kind of thing. It's more like, oh, this is a tactic, it's a strategy that I could use when I'm troubleshooting. In the first one, I talked about the science and art of troubleshooting always-on availability groups. The second one, I talked about how I do my troubleshooting. I can't remember the other one, but this one is all about using the client-server model to troubleshoot always-on availability groups issues, right? Using the client-server model. We've had a client-server model. I mean, the client-server model is something that we have been using for decades and decades and decades. It went back to the days of the mainframe where you have a dumb terminal. It's a simple console that connects to the mainframe, and what ends up happening was that the dumb terminal happens to be the client. You're sending requests to the server. In that case, happens to be the mainframe response, and then you get the client, which happens to be the dumb terminal, gets the response from the mainframe. And we've been using that in our day-to-day. When you have a smartphone, okay, your app on your phone happens to be a client connecting to a server somewhere. If that's Netflix, connecting to the Netflix servers. If that happens to be Amazon, it is connecting to Amazon servers. It's so ubiquitous, if I can use the word. It's so all around us that sometimes we don't pay attention to it. And the basics and the fundamentals of how it works and how I use it to troubleshoot always-on availability group issues. I want to first, again, set the framework for how it works. And I've kind of given that example earlier on how to use, or how the client-server architecture, the client-server model works. You have your client, and then you have your server. Again, it's no different from you running a browser on your computer, visiting a website. Okay, your client happens to be the browser. We'll just use that example, right? You're visiting Google.com. The browser happens to be the client, and then the web servers hosting Google happen to be the server. Of course, single entry point to the server, but let's pretend it's just one server. Client will initiate a request to the server, okay, and then based on certain things, okay, which I will explain as we go along, but based on certain things, the server will then respond back to the client. In our case, you go to Google, you type www.google.com, and then the browser sends that information over to the server responds back. That is kind of like the high-level overview of how a client-server model or a client-server architecture works. Like I said, it's so ubiquitous, like every day. We see it day in and day out. You open your weather app on your phone. The weather app is the client. It reaches out to an API hosted on a server, and based on a couple of things, right? Based on a couple of things, which I'm going to talk about, the server responds back to that request. Okay? There are 4 things, and I said, like I did mention, there are things happening under the covers that we barely pay attention to, but very, very important because these are things that are happening whether you know it or not. There are 4 things that client applications need to successfully connect to a server. There are cases when you would open up your browser, type www.microsoft.com or google.com, or based on the recent AWS outage, aws.amazon.com, and then all of a sudden you don't get a response. Okay? Because there are 4 things, or I forgot, 404 error, because there are 4 things that the client applications need. In that case, the browser client applications need to successfully connect to a server. What are those? The first one is the FQDN or IP address, like the fully qualified domain name or IP address. Okay, I don't like memorizing numbers, and I'm pretty sure nobody knows at the back of their head. Nobody knows what the IP address of www.microsoft.com is, unless, of course, you're the engineer monitoring the status of the website. Okay, we don't. In fact, nowadays we don't even memorize phone numbers. That is where the fully qualified domain name comes in. So in this case, it could be the fully qualified domain name, hostname.testdomain.com, or an IP address 10.254.254.17. You can think of this like the main phone number in an office. Okay, somebody calls your office, they dial the main number, and you can think of the fully qualified domain name or the IP address as the main phone number in an office. Okay. Transparently, though, again, you might be thinking, wait a second, I don't key in an FQDN or an IP address whenever I open up Amazon on my phone or Instagram on my phone. Of course not. The app already has that embedded within it. And that's why whether you're switching phones or you're using a different device, the app in and of itself already embedded the FQDN or IP address. Of course, it would make sense for you to embed an IP address because it could change somewhere down the road. Okay, that is already embedded within the app. However, if you're using a browser, you have to explicitly type the fully qualified domain name, like www.instagram.com or www.microsoft.com. You have to put that in there. And again, this is happening in your app, whether you're aware of it or not. Okay, so that's the first one, FQDN or IP address. And I say FQDN or IP because, again, as humans, we don't really remember IP addresses. Okay, and also because of the nature of the cloud, the scalability of infrastructures, the IP address could change. Like in the case of an availability group, the IP address could change depending on what you're trying to do. Maybe you're scaling out services, you're scaling out the servers for your APIs, so you're hiding that behind an abstraction layer. Okay, but of course, not a good idea to use IP addresses. That's why we use human readable sources, like a fully qualified domain name. That way, if you're using, if you're accessing, let's say, Instagram or Microsoft.com, Microsoft can change the public IP address assigned to www.microsoft.com, and then you can still, okay, connect to the website regardless of whether Microsoft changed that IP address or regardless of whether Instagram changed that IP address. You can still connect to it. Everything's transparent. Your entry point is the fully qualified domain name. But again, I did say 4 things. This is just the first one. The second one is the port number. This is for SQL Server. So imagine, okay, imagine opening up your browser, typing www.instagram.com. By default, you're not typing anything after the fully qualified domain name or the IP address if you know what IP address. You're not technically putting in the port number. But by default, if it's HTTP, it's port 80. So you can type fully qualified domain name :80 and you'll get redirected to HTTP. Of course, by now, the standard has been to use HTTPS. So anytime you're hitting HTTP, you're getting redirected to HTTPS. And whether or not you type the port number, HTTPS will append the default port number, which is 443. Okay. Similarly, with SQL Server, you're connecting to SQL Server using SQL Server Management Studio, your client applications. You're providing either the instance name or, in the case of an availability group, the listener name, which could be a fully qualified domain name or just a host name or a virtual name. And even if you type, even if you don't type, rather, the port number 1433, you're still going to get redirected to SQL Server and to the database. Okay, this is its default behavior. Okay, like I said, you open up your app, the weather app, Instagram, Amazon, Netflix on your phone. It is already embedded in the app, the fully qualified domain name and the port number, whatever port number they're using to access their API. So you can think of the port number like an extension after you're calling the main phone number to your office. So you pick up the phone, you dial the main number, and then you get a prompt, type the extension. Okay, so you got into the main line, main telephone line, and then if you want to reach the specific person, you dial the extension number. You can think of this as the extension number attached to that. Why is that? Because your servers are actually running multiple services. On a Windows machine, you're running remote desktop, which is listening on port 3389, 43, can't remember, which is listening on a specific port number. That is why when you open up remote desktop, you connect to a remote server via remote desktop. You don't have to append the port number. Of course, it's different on the cloud because you have to open up some firewall rules, so they redirect you to a different port number. But again, when there are default port numbers, you don't have to explicitly define them. They will be used automatically as part of the app. In the case of SQL Server Management Studio, if you don't provide a port number, it will automatically connect to 1433. I was actually talking to one of the vendors. Yeah, he was one of the vendors, one of the sponsors at an event in Poland last week, and they were explaining how they had a customer where they had multiple SQL Server instances in the same machine. Okay, multiple SQL Server instances in the same machine, and they have to figure out, am I going to be using 1433 or other port number for the other instance? The default instance, you can use 1433, but for the other named instance, it could be something else. Okay, now, of course, we're talking about availability groups. That same thing also applies to port 5022. Okay, so those two have to be there. It's not enough for you to have an access, not enough for you to get redirected to port, or rather the IP address or the fully qualified domain name, if the port number is not opened. I'll give you an example. You have your SQL Server service running on a machine with a certain fully qualified domain name, say hostname.testdomain.com, but then when you open up SQL Server Management Studio and connect to it, you can't connect to it. There are a couple of reasons for that. Okay. One, you can't go through, meaning the fully qualified domain name is not consistent with a corresponding ID, and you can't, the client, or in this case SQL Server Management Studio, cannot find it in the network, and so it is not able to go through. The second one, of course, is potentially port 1433 is not open. Why? A couple of reasons too. Could be firewall, could be that the SQL Server service is not running. So even though you have access to the IP address, if the client application cannot connect to the port number, you won't be able to. Moving on. I did say 4, right? The third one is authentication. Okay? This asks or answers the question who's trying to access. In the context of accessing a website, everybody is authenticated. Really. Even if you do, even if you open up your browser and type www.google.com. Wait a second. Are you telling me I'm authenticated? Yes. In order for Google or Microsoft or Instagram, and this is outside of the authentication that you do when you click sign in. Okay, this is outside of that. The mere fact that you're trying to access a website, a global public website, means you're already being authenticated. But wait a second, you might be thinking, I'm not providing any credential. And that is correct. You're getting authenticated as anonymous user. That is why you can open up your favorite browser, Netscape Navigator, for those of you who remember. You open up your favorite browser, you type in the fully qualified domain name, include a port number if you want to, and you can see the website. The fact that you can see the website means you've gone through those 3 steps. FQDN or IP, port number, and authentication. You're passing your credential. Well, wait a second, I did not pass my credential. Yes, you are passing an anonymous user credential to the server and you're getting authenticated. I mean, imagine that if a public website like Amazon.com has to authenticate every user, how can they browse items that they need to buy? Especially if this is the first time I visited the website. Okay? So authentication is happening. It's just that on a public website, you're getting authenticated as an anonymous user. Make sense? Okay? This is part 3, or the third thing that client applications need in order to successfully connect to the server. But connecting to it is not enough. Getting authenticated is not enough. The fourth one is authorization. It answers the question, does the user trying to access have permissions? Okay. In the case of a website, a public-facing website, you typed www.amazon.com. You didn't have to provide port 443 as the port number because it automatically redirects you to HTTPS. You're logging in as an anonymous user. An anonymous user has access to the website, has permissions to access the website. That's why you can, once you get to Amazon.com, you can start clicking and navigating and browsing all of these products. Of course, you're not going to be able to buy until you either create an account inside the portal, inside the website, click sign in, and that's the only time that you can continue with the purchase. But you can browse, and that is in and of itself accessing the contents of the website. You can browse, you can look through all the different products on Amazon.com. On Netflix, you can go through all of the different movies, but you won't be able to watch it until you've signed in. But this in and of itself is enough for you to be able to go visit a website and browse the contents of a website. Okay? The purpose of that, of course, marketing. Otherwise, nobody's going to be able to see what's on your website if you're not allowing anybody to access the contents. Okay? So these are the 4 things that the client application needs. Okay? 4 things that the client application needs. Quick recap. FQDN or IP address, port number, authentication, and authorization. I use the client-server architecture or the client-server model whenever I'm building an availability grid. And I'm not even talking about from the point of view of the client application trying to access the database. Okay? I'm talking about the fact that when you look at a typical always-on available group, like in this case, you have a 2-node Windows Server failover cluster with a 2 replica. Generally, even if you don't have a failover cluster. Okay? Even if you don't have a failover cluster. But the fact that you're always on availability groups are consists of multiple replicas. The way I look at it is, here's your primary replica, and that is acting as the server. Okay, here's your secondary replica, and this is acting as a client. What do you mean by that? When you build your always-on availability group, part of the process is for you to provide primary and secondary. With a primary and secondary, well, before you get into that, if you go through the wizard, part of it is defining the port number. Or maybe you're not familiar with the port number term inside SQL Server, we'll call it the endpoint. The endpoint is actually a combination of the fully qualified domain name and the port number. Here you would see it's a TCP endpoint. In the case of the server, tdprd021.testdomain.com, that's a fully qualified domain name with 5022 appended to the endpoint as the port number. So far, so good, right? So that's part of it. First part is providing the endpoint. And if you recall, within the wizard, you also have to provide the SQL Server Service account. Because the SQL Server Service account happens to be the one that gets authenticated. Remember the 4 things? SQL Server Service account happens to be the one that's getting authenticated to the primary replica. Okay? And then authorization, it's also one of the reasons why you grant the connect on endpoint permission to the SQL Server Service account. Okay? The way I look at this is when you're building the always on available group, you start with a primary replica, which happens to be your server, and then your secondary replica functions as a client. Okay? You see that arrow in the diagram. The secondary replica will reach out to the primary replica and say, hey, give me all your transaction log records. But it cannot do that if those 4 things are not satisfied. Okay? It cannot do that if those 4 things are not satisfied. So whether you're building an always on availability group and you get this error 54G4, I forgot the error number. Anyway, you cannot add a replica to the available group. Those 4 things will tell you why. Okay? Again, look at your secondary replica as a client application trying to connect to the primary replica. But, and this is a scenario that will always happen. At any given point in time, a failover will happen. Maybe your primary went down, and so, of course, the assumption is you have something like a cluster resource manager, like Windows Server failover cluster. Primary went down, cluster will trigger an automatic failover, so there's role reversal, meaning what used to be the secondary replica now becomes your primary replica. And what used to be your primary replica now is your secondary replica. Therefore, the client-server model now switches, the role reverses to where the new client is now the former primary replica, which is now a new secondary replica. And the new server happens to be the new primary replica, which happens to be the old secondary replica. Even the fact that this failover process works, this right here, in order for this to be successful and replication to be successful and the whole thing returns back to business as usual, it still has to follow the 4 things that every client application needs to successfully connect to a server. Fully qualified domain name, a port number, authentication, and authorization. Same thing. Okay? In this case, fully qualified domain name and port number is your endpoint. You have your fully qualified domain name plus port number with port number 5022. Authentication, in this case, it's the SQL Server Service account of the former primary replica, in this case, the SQL Server Service account of TDPRD021. And then permission, the authorization. Is that SQL Server Service account granted to connect on endpoint permission? Because if you don't have any of those, even the failover process is not going to work. I've seen so many cases in the past where a failover did not happen, rather, because one of those conditions were not satisfied. Makes sense, right? And again, we'll look at this as an example. This is something that I highlight, or I show a couple of my customers to illustrate how the client-server model has helped troubleshoot this issue. When you look at the screenshot, you have a primary replica and 3 secondary replicas. But in this case, 2 out of the 3 secondary replicas are not synchronizing, which in this case, your availability group is at risk, which means it will not be able to automatically fail over to TDP-RD022 and TDP-RD023, despite the fact that they were configured as synchronous commit and automatic failover, okay? Because they are not synchronizing, okay? And this is one of those situations where I would use the client-server model as a framework to troubleshoot why. Now, in this case, there's no outage. I got 4 replicas. The primary can still fail over to TDP-RD024 automatically because it's configured with synchronous commit and automatic failover. And it's synchronized, and it's healthy. So I can still afford to have a situation like this where I've got no outages. However, I need to resolve the issue from the other 2 replicas in order for me to prevent a potential outage, because there's a couple of different reasons or a couple of different issues that could come up from this if I don't resolve connectivity to TDP-RD022 and I did give it away, didn't I? Connectivity. Because when it says not synchronizing, there could be a couple of reasons. Could be that the primary could not connect to the secondary, okay, using the fully qualified domain name, port number, authentication, or authorization. Those 4 things, okay, could be. And so I test those 4 things against connectivity between primary and TDP-RD022 and TDP-RD023, okay. Of course, assuming that in the beginning this was properly set up, everything was healthy, and then all of a sudden this happened, and now we can no longer synchronize the other 2 replicas. I highly recommend that you take a stab on the process on how to get this thing resolved using the client-server model. Okay? Because again, it might not look like, oh, I don't have an outage, my AG is just warning, but I can still connect to it because the primary is still active. My listener name is still active. Yes, but unfortunately, because one or more of your secondary replicas is, in this case, not synchronizing, it will not be able, or the primary will not be able to truncate the transaction log regardless of how many times you run backups. And when that happens, it will fill up the entire drive. It will cause your availability groups to become unavailable, take it offline because its transaction log file can no longer be written to. Okay, I highly recommend that you take a stab at the process, put it in the comments, or send it to me via DM. Take a stab out of this. Try and figure out how you can identify the issue. Step-by-step process using the client-server architecture or the client-server model. And again, just brainstorm and see how you could potentially solve this problem. All right, that is about it for this week's episode of the Practical SQL Server HA show. And this is, again, just me giving you kind of like the framework of how I use the client-server model to troubleshoot always-on available group issues. And keep in mind, the assumption here is, of course, the AG is still up and running, because if the AG is not up and running, well, this is not how we're going to resolve it. You go back to the episode where I covered the workflow process on how I deal with outages. But in this case, clearly the availability group is up and running. Databases are healthy. It's just that there are issues with the availability groups. And again, take a stab on trying to figure out what the problem is, what's your troubleshooting methodology, what the process is like, step by step, so you can proceed to resolve it. Okay, again, that's about it for this week's episode of the Practical SQL Server HA show. I really appreciate some of the feedback and the comments that you guys are sending over via direct message, via email. Thank you, really appreciate it. It's how I come up with these topics. So again, feel free, reach out, use the comment section, and I will incorporate some of those topics in future episodes. That's about it. And again, if you need any help with anything related to always on availability groups, or in general, high availability and disaster recovery, whether you're still in the process of planning for deploying a high availability solution, maybe you need a second pair of eyes to evaluate whether or not what you did was correct. Because the last thing you want is for you to deploy it in production. You've already done a production cutover. Next thing you know, you realize, there's a lot of risks that we need to mitigate with our deployment. Use that link on the screen. Schedule a strategy session and reach out with the strategy session. The goal is twofold. One is to be very, very, very clear about the goal that you're trying to accomplish. A lot of my customers in the past would reach out, hey, we've had this outage for a couple of times now. We needed to figure out what the root cause is, because it's costing us hundreds and thousands of dollars for every outage that we've had. So my customers reach out and ask me to guide them through the process of deploying an always-on availability, both for high availability and disaster recovery, and integrating them within their existing solution. Some of my customers are using enterprise backup solutions like IBM's TSM, or backup exec, or any type of enterprise backup solution, and they want to integrate that to their existing HA and DR strategy. Again, use that link on the screen. Schedule a strategy session. By the way, this would lead you to my calendar page where you can pick and choose a time that works for you, right? And I certainly look forward to speaking with you. And what I do is, again, we'll walk through some of the things that will help you get clarity on the issues that you're facing and the next step. And if I can help, I will. If not, I will steer you, steer you to the direction that would help serve you best. All right? Enjoy the rest of your week. I'll see you again in the next episode. Goodbye.